Just imagine a world where cancer isn't even a real threat. Situations like the one that I'm about to show you would be nowhere near as stressful or as daunting.
Mr. Balboa, thanks for coming in on such short notice. Well, we went through your test results, and your biopsy came back showing signs of large cell non-Hodgkin's lymphoma.
What's that do?
Well, it's a form of cancer.
I mean, seriously, if Rocky Balboa, the freaking heavyweight champion of the world, is scared to fight cancer, then us average Joes have little to no chance. Well, that's what you might think. As you can see in this table, if we can catch cancerous tumors earlier, then patients will have a much higher likelihood of surviving. And thanks to artificial intelligence, we can do just that. Huge companies such as Google are already tackling this problem. To learn more in depth, you can read my article, which is linked down below in the description. Neural networks are actually inspired by our brains. In our brain, neurons are connected to one another, forming networks. Once an electrical input passes a certain threshold, the neuron is activated, and it sends the electrical signal forward to the next neuron, and so on and so forth. And this is how messages are relayed across our bodies. Computers use this same idea to detect complex patterns in data that us humans would never be able to see. And trust me, you don't want to go looking for those complex patterns. Not the best idea. In our case of classifying if a breast cancer tumor is benign or malignant, I got such a dataset from Kaggle. In this dataset, there are 9 features such as mitosis, bare nuclei, and chromatin that determine the state of the tumor. This problem is a binary problem, meaning it's one or the other. It's either benign or it's malignant. To help the computer understand this, and so it can detect its own accuracy, I labeled benign cases with 0 and malignant cases with 1. Once the data is manipulated in the way that we want, we can actually feed it into the network. And after each iteration in the network, it compares its predicted output to the actual output. And then it makes tweaks to the weights and biases to make the predicted output even closer to the actual output, which in turn makes the entire model just more accurate. After iterating through our data many times, our model became 96% accurate. That's pretty good. With that being said, there's still a long way to go before artificial neural networks like this one are actually implemented into the medical field. But I hope that sometime in the near future, pathologists and artificial intelligence can work symbiotically to help diagnose cancer and also make people like Rocky a little bit more optimistic. See you guys soon.